Okay, hello everyone. Let's get started. I'm going to start by introducing myself. I'm Vinod Kurpad. I lead the Azure AI Document Intelligence product team. And today I'm going to be joined on stage in a little bit by Jacob Wilson, who's the CTO for Generative AI at PwC. And we're going to be walking through how Generative AI is transforming document processing. We're going to start by looking at some of the new capabilities, specifically Azure OpenAI models and how they really transform the way we work with documents. We're going to start by looking at RPA, or robotic process automation, and how generative AI is really simplifying the way we work with documents there. We'll also look at what's driving the explosive growth in RAG and the amazing interest we're seeing around RAG. And then we'll wrap things up by walking you through some of the newer capabilities within document intelligence that'll help you build a complete document processing solution, right? So it's a set of different things, but we'll work through it as we go along. When you think about generative AI, right, the core thing that we notice is these models are really amazing at just understanding the content, the structure, and the relationships within your documents. And this opens up a wide variety of opportunities of how we can interact with these models for exploring documents, analyzing documents, comparing, and even generating documents. So generative AI, with generative AI, it really does make RAG possible, right? RAG didn't exist as a pattern until generative AI. But when you think about RPA, or robotic process automation, generative AI is really simplifying the process there too, and it gives us new ways of how we can think about extraction, post-processing, validation, and even an agent-based approach to using automation with generative AI. Within RAG, so if you think about document chat, that's sort of the most canonical use case for how RAG pattern is used today. Models like GPT-4 from Azure OpenAI, you send in your document, you can ask a question, and it gives you back a response that says, here's the answer to your question. And that typically works because you're taking the document content, it's extracted from the document, you break it up into manageable chunks. Each of those chunks is then vectorized or embedded, added to the search index, and then the most relevant chunks from the index are then used to answer the question that produces the answer that you're interested in. As you think about that ingestion process, some of the core requirements from this is obviously garbage in, garbage out. So making sure that you can extract the content effectively, recognizing what the structure is, understanding how that structure plays into answering the question, and then making sure that the model recognizes all of these different nuances within the document. Those are all challenges that we'll be talking about in a little bit as we go through the presentation today. The other thing that I also want to call out is while RPA is sort of a newer, while RAG is sort of a newer concept, the automation of work within the automation flows is also something that RPA is starting to get embedded into. So RPA is not just a question of saying, I want to chat with my documents, but it's about taking these concepts of like understanding document similarity and then embedding that into your workflows. And so as we talk about workflows, one of the most common sort of canonical patterns that we see within document intelligence starts with classification, right? So you start with classifying your document. The next step in that process is then using the output from the classification step to then determine which downstream model you want to send your documents to for analysis, analyzing the document with that particular model, extracting the fields that you need. And then there's a little bit of transformation or post-processing required in order to ensure that your schema matches the output schema. Finally, you go through a review stage where you look at the outputs of the model, you look at the outputs of the document that you produced, and you ensure that it's the highest possible quality that you can use for your downstream systems, and then it gets persisted or stored into some sort of a structured store. So the challenges that we see with some of these processes are, for example, in classification, you might run into a scenario where you have subtypes of documents, right? So an example might be a IT services contract versus a marketing contract. Do those two need to be treated the same? Do they need to be treated differently? There's a lot of variations in these things that you need to be aware of and pay close attention to. Another common challenge is splitting documents, right? So you get a loan application that contains 7 different documents. those need to be split apart, so a single file containing multiple documents. The next set of challenges that we typically see with extraction is challenges with templates and challenges with complex structured representations. So when you have, for example, we'll look at a little demo in a little bit about, you have a form that contains many different variations. Invoices are a great example of this, right? So every company can create an invoice, and each invoice looks different. How do you extract the right values from those? The next set of challenges is around post-processing. When you talk about post-processing, these could be things like, you have a name and address field as an example that comes in as part of a form, but your database has two fields, a name field and an address field. So you need to do some post-processing to then extract these, separate these two values out, put them into the appropriate fields. You might have other things like maybe a patient lookup to ensure that any prescription that you're filling out is a real valid person, and that person is actually in your database of patients that you can actively fill prescriptions for. And finally, as you look at the confidence scores, so confidence scores is sort of the capability of ensuring that your model can extract all the values accurately, and you want to minimize the amount of human review. So as you look at this, it's sort of a trade-off between human review and confidence scores that allow straight-through processing. So you're trying to maximize your straight-through processing, but also minimizing your errors at the same time. So that's sort of the trade-off that you're applying during the confidence score sort of process. And finally, as you look at these outputs from these models, you also want to make sure that any outputs you correct or validate as a human, you're able to take those back into your model building process to then improve the model for the next iteration of documents that are coming through. So as we look at sort of the way OpenAI is transforming the way we process documents, for today we're going to focus primarily on the extraction aspects of things. So when we think about all of the amazing things that you can do with Azure OpenAI models, there are a few challenges as you think about like how it sort of works in the RPA pattern today. Those challenges are sort of in two major buckets if you want to think about that. The first challenge is essentially how do you work with the models themselves, right? And in this we see a lot of challenges around your prompt sizes tend to grow exponentially as the complexity of your documents increase. Because you see that each new document variation, you need to make some adjustments to your prompt, and as a result, your prompts continue to change and evolve and grow. The second challenge we also see a lot of is inconsistencies in the way the model responds for even the same document. So you might send the same document in 3 different times, and you'll get 3 different responses back in terms of what the actual answer is that the model predicts, which is really something that the RPA systems don't really work well with. The next set of challenges are more around process, right? And so when you think about process challenges, RPA systems really require grounding. And when we talk about grounding, it's about veracity, right? It's about ensuring that you can point to a specific span of text in the document that says, this is where this value was extracted from. And how do you ensure that you can now trace that information back to that particular document so you get that result back? The last sort of challenge as you think about RPA is confidence scores, right? Confidence scores, like I shared earlier, is about ensuring you have straight-through processing. With Azure OpenAI kind of models, you don't really get any sort of confidence in the value that's being extracted, and so you need to define what your strategy needs to be in order to address this. So with all of these sorts of challenges, right? These are the kinds of things that we've been thinking about within our team to say, like, how do we solve some of these complex challenges? So today, I'd like to share with you that we're working on a new model type called custom generative, right? And custom generative is essentially a generative AI-based model that works really well for extraction scenarios. We started our journey with a new feature called query fields that we launched in early 2023. And now we're sort of taking that and adapting that to the extraction task. So let's take a look at like how custom generative helps you with all of your document extraction challenges. To do this, we're going to walk through a series of videos. I'm going to try to help you along, sort of follow along. So I'll set things up a little bit for you. So this is the new AI Studio, where you're going to start with anything you do with Azure AI. All of those experiences are going to be sort of added into the new AI Studio. Custom generative is going to be available in the new AI Studio as well. So in the new AI Studio, you're going to start with the Document and Vision tab. and you're going to go create a new custom extraction model. So as you go through this, you go ahead and you hit the new tab to create the extraction model. You give it a model name. There's three things that you need to care about here, right? First is you're defining your project itself, which is a connection between your AI resource and your data set. I've skipped through some of those steps of actually connecting to your data set in this step, but when you end up with your project created, you'll be at this first step in the workflow, which helps you define the schema of the documents or the fields that you want extracted from the model. On the left is, So on the left is the schema. On the right is the actual documents that you uploaded as part of your training data set. So the next thing we're going to do is go ahead and define the schema of the fields we need. So this is essentially, as you think through this, the first aspect that I would really want you to focus on is the fact that the new custom generative experience transforms the way we're building models. Right? In the past, we really focused on a label and train approach, but now we're really translating that experience to be more of a validate and correct experience. So the model does a lot of the work for you, and as a human, your job is really a lot more simpler now, and you're essentially only correcting the model for the most part. So the next thing we're going to do is we're going to go and add some fields in, right? So in this case, I'm dealing with a document type that is essentially a prescription approval form. So I've got a few different variations of this. I'm going to add a few fields. These are the fields that I'd like to extract from these documents. You can see that there's a variety of different field types I can extract. So depending on the field that I want, I can choose the field type that I really want, right? So it supports the same fields that we used to support, things like strings, numbers, even tables. So I've gone ahead and added a couple of fields. I'm just to show you what the process looks like, but then we'll go ahead and add a few more fields. So at this point, you've essentially got all of your fields added into the schema, and this is the first real magical element of what custom generative can do for you. Once I've added my fields into the schema, I hit save. The zero-shot model runs, and it starts to extract the fields from each of these documents for you. So let's take a look at what the zero-shot model can do. So when you look at the output from the zero-shot model, it actually gives you the fields that you wanted, as well as the values that are grounded in the document. So it tells you where in the document this particular value came from, and it gives you a confidence score for each of the values that it extracted. So those are the key elements of how this model is able to essentially conform to the requirements of what most RPA systems require, right? So it's giving you the veracity of information of where this document or field was extracted from. And if you look at the different documents that it's extracting from, you'll see that even though the templates are dramatically different, it's still extracting all of the values that you needed with the accuracy you require, as well as the confidence, right? So this is essentially one of the core competencies or the core value propositions of the model. The next part, so at this point, you've got 3 documents that you've added. You've validated that the model can extract the values that you require. So at this point, all you would need to do is hit that build button at the top of the page, build the model, and now you have a publicly addressable endpoint that you can use for inferences on documents like this, right? And so this is how simple it could be for most document types that you need to create a model for. All you need to do is define the schema, and for the most part, for fields that are not very ambiguous, the model should be able to extract the values that you need without any training required. So that's the first step of how you work with custom generative models. Now, I know a lot of you are sitting there saying, well, Vinod, that's great. It works for these simple forms, but I've got more complex documents, right? And it isn't as easy as this for the most part. So I'm here to tell you that actually custom generative will work for all of those scenarios as well, right? It's not just for simple forms. So let's take a look at what a custom generative experience might look like for more complex forms. We'll start with a document type that is a 10Q document. For those of you in the US, it is a typical document that most publicly listed companies have to provide for their quarterly earnings. It's a long document. In this case, it's about 60 to 70 pages. It has lots of complex information in it. And let's take a look at what that experience might look like. So like any good cooking show, I've skipped through the project creation process. I've skipped through the field creation process. I'm an analyst now. I've defined a set of fields that I want extracted from a 10Q document. You know, these might be simple fields like the ones I've selected here, but it could be more complex fields as well. We'll go through the process of adding a couple more fields because there's a couple of things that I wanted to call out as we do this. So the first thing I'll call out is the name obviously needs to be meaningful in terms of what you're trying to extract. You've probably seen that based on the things you've seen so far. The second thing I'll call out is this description field, right? When you add a new description, it's not just for the human that's creating the model. It's actually for the model itself. So anytime you give the model a description, you're actually telling the model where in the document this information might be, how it might be represented, what are the relationships of this to other things in the document. There's ways that you can hint to the model how it needs to use this information. And then the last thing I'll do is add a second field. In this case, I'll add a field that I'm going to call quantitative and qualitative risks, right? So it's essentially, think of this as, in every 10Q document, there's a management discussion section. And so that's what I'm going to use in my description as well to say, I expect that this is going to be in the management's discussion section of the document. So I've got my schema generated now. And I've defined all the fields that I wanted. So now we'll go through the same process again of letting the zero-shot model do its thing, right? So I hit save, and once I hit save, the zero-shot model should start analyzing this document. Hold on a second. Oops. I went ahead. All right. So at this point, the zero-shot model analyzes the document. We'll click on a few fields. We'll see what the values look like, right? And you'll see that the fields are extracted right, even though they're from different sections of the document, right? Some of these fields are just standalone fields, like this, like quarterly end date is a standalone field. Then there's fields like these that are in tables. Then there's fields that are inside a paragraph. The model just knows how to deal with all of these different complexities within the document, and it can extract the fields that you need from the different parts of the document, depending on the context of what you're trying to extract. So you're seeing the zero-shot model, again, works for most of the simple fields that are sort of easy enough for the model to understand what these are. But we're now at this quantitative and qualitative risks field. And you'll see that it's only extracted that first paragraph of text in there. I actually expected the model to extract the entire section, right? Down to the point where we talk about the secondary analysis or sensitivity analysis. So I expected that entire section to be extracted. So here's the next interesting way of how custom generative addresses this problem. Rather than you having to define what prompt improvements you need to make, or how do you change your prompt, and how do you make sure that same prompt works for different documents at this point, all you need to do with custom generative is label that field. Right? So you go ahead and you label the field. So once you label the field, you'll see that the model, so this is the process of essentially labeling the field. You define the span of text within the document that you want. You go ahead and add that in as a label, and now your document is labeled. So this, when I talked to you earlier about saying we're changing the experience from labeling to validation and correction, this is essentially the correction part of that validation and correction experience. So you've now corrected the model, and you've told it, I want you to work on this field slightly differently. So now we'll take this example and we'll apply it to the next document in the process, right? And you'll see that the model now intuitively understands what you're trying to do and starts applying those corrections to the next document. The next document is a different company, looks different, the fields are different, the structure is different, the format is different, but all of those fields that you wanted are still extracted. And if you go look at the qualitative and quantitative risks field, you'll now see that it's actually extracting that entire paragraph of text, or not just the single paragraph, but the entire section of text that you really wanted for that particular document or that particular field. Again, when you do this, all you're doing is essentially correcting the model on the few fields that it's not quite getting right? And so generative AI may be great at most things, but even generative AI can miss. And when it does miss, you still have the option to improve the model and correct it as it goes through the process. So the next thing that I, as an analyst, might want to do is add a couple more documents, validate that it's extracting the fields that I need, right? Once I feel that looks good enough, I can go ahead and hit build. I now have a model that works for a complex document like a 10Q to analyze and use the output in my downstream processes. So the core sort of capabilities that are underlying this is the understanding of the structure of the document, so we can essentially use that structure to generate the right representation of the document for the model to extract those values that you need. And this comes from the layout understanding of the document. So it's the sections, paragraphs, tables, images, charts and graphs, and things like that. There's also word level grounding. So you can point to, or you have the veracity that you need to ensure that you can point to the specific section of a document where this particular value is extracted from. And finally, the confidence scores that help you with the straight-through processing needs that every RPA processor needs. So as you look at the maturity of RAG versus RPA, RPA is a much more mature process, and integrating generative AI into an RPA process requires that you do some of these things to ensure that it fits into the process well. And you can see that we're able to do all the things that we needed to do in order to ensure that a generative AI model can really be applied to the RPA workflows. So custom generative as a new model type is going to be available in Document Intelligence. This model should be available sometime starting later this summer. I've got the QR code on the screen. Please scan this if you want to be notified of when the model is available. We'd be happy to send you a notification. There's also a little section in this forum where you can send us any other feedback or questions. If you have any questions about Document Intelligence, we're happy to answer. Just let us know. We'll reach back out to you. So we talked a little bit about how generative AI is transforming the robotic process automation, RPA space. But generative AI is not just about RPA. It's also about document chat, or RAG. And in order to do that, I'm going to start by actually rolling a video of how one of our customers, PwC, built a solution that uses generative AI for PwC chat.
The Gen AI revolution is here. It can transform industries and create countless opportunities. PwC is rising to the moment. Introducing Chat PwC, the Gen AI tool to help you get work done. Accelerate productivity. Drive innovation. Discover hidden insights. Go further, faster. For our clients, our people, and our firm. It's safe, it's secure, it's ours. The Gen AI revolution is taking off at PwC. We are human-led and tech-powered. Now, we're superpowered.
Wow, that's pretty awesome. So rather than me trying to explain to you what PwC built, I've invited Jake Wilson, the CTO of Generative AI at PwC, to come on stage with me and share what PwC is building with Gen AI.
Yeah, thanks, Vinod. So hopefully I give you a little shot of adrenaline, kind of on your last day of build. Jake Wilson, so I've been helping lead a number of our generative AI efforts internally at PwC, also helping a number of clients in the market, just in terms of really how do you scale this across an enterprise. You know, with Chat PwC, we've rolled that out to 200,000 PwC professionals globally. One of the main capabilities behind that is all the RAG pipelines in terms of all the data that's getting uploaded for our different financial due diligence tasks, audit tasks, tax-related activities. Also, as we think about like the different sectors that we're supporting with industrial manufacturing, biotech, et cetera. So a lot of information goes in through that application in terms of how we're processing that, using that as context to ground the output for like GPT-4 as an example. So I think it's important, like as we talk about Azure Doc Intelligence, really that is kind of a core building block as you think about the overall RAG ecosystem. So today I'll kind of explain a little bit more about how we look at the RAG architecture overall, where Azure Doc Intelligence kind of fits into that RAG architecture, and then we'll go through some examples with paragraph chunking, table extraction, and show a few code examples around that. All right. So RAG architecture. This is pretty rapidly evolving ecosystem. When you saw the paper, I think it was like 2 or so years ago that originally came out, 2 or 3 years ago around RAG. It's very simple, right? You basically, you load in, you do your text embeddings, and then you load that into some type of vector database, and then you encode the prompt, and then you do the similarity search against the vector database. If you look at the RAG ecosystem today, it's a lot more complex. There's a lot of different techniques in that upfront process to where you'll do the chunking and embedding, but also when you get into the details of the retrieval and how do you take a very light prompt from a user or very specific instructions, and how do you actually get it to retrieve the information you want once you have it in your hybrid search solution. So as you can see on the bottom, there's a lot of different things in terms of how you take a user prompt. You'll do what's called hypothetical document embedding, and that's actually how you're expanding out kind of the verbose language to then use for the semantic similarity search downstream. Also different ways in which, if you look at for us today, because we use Azure Doc Intelligence at the front end of the process, but also we use Azure AI Search within the knowledge base. And there's a lot of things you can do with Azure AI Search as well in terms of aggressive KNN retrieval versus an HNSW algorithm, and how it's kind of finding the nearest neighbors related to the semantic lookup. And also using a combination of vector, semantic, keyword search to help optimize the retrieval, and then the re-ranking profiles around that, from scoring profiles to semantic profiles. Again, all in the spirit of optimizing what it is you're retrieving to provide for the context LLM. So that ecosystem is very big, and it's continually evolving. I think what we'll focus on today, again, just for limited time, just kind of the front end of that process. So Vinod mentioned garbage in, garbage out. If you're not doing a good job at the front end of your process, likely your retrieval is not going to be great. So we use Azure Doc Intelligence at that front end of the process to help with the overall kind of document understanding, and then identifying different paragraphs, tables, images within the document, and that informs our downstream processes. So here's an example. I won't go through all the details here because this is a lot of text to read through, but essentially the less color coding, the better. In terms of, we ran a few different evaluations with LangChain, semantic kernel, a number of other different open source libraries and things like that to help us with our chunking strategy. And what you'll see on the right is a very clean delineation of the page header, the paragraph header, and then the actual chunks of the text related to the paragraphs. Versus everything on the left, you kind of get a mix and match of different things, which is not what you want. So with Azure Doc Intelligence and a little bit of post-processing that we kind of have in that pipeline, we're able to get very clean delineation of the paragraphs, the header information, which is extremely helpful for the chunking process when we start to move that downstream. And that gets you, reliable results at scale like we were talking about earlier. So if we move next, here's a little bit kind of deeper dive. So we just saw kind of paragraphs. Now you can kind of see the tables coming into the mix here as well. So on the bottom right, you'll see kind of how Azure Doc Intelligence is identifying the tables and then providing that output in a very kind of clean, parsable format to kind of get that information out of the actual table. Now, when you look at a RAG pipeline, sometimes you're not going to actually do chunking of the table itself. If there's not a lot of descriptive information in there, like it's a pretty clean table, financial figures, you'll just take the whole table itself and go load that in the index in Azure AI Search, and it'll look for the full table content when you do the retrieval. In some cases, you might want to break it up, but what's nice about Azure Doc Intelligence is it's going to clearly kind of pull out all of the table header, the table row information, so you can kind of split that up any which way you want. In terms of, I can use the table header information as metadata tags for the chunks for the content and the actual table row. And I can kind of send all that downstream, load it into Azure AI Search to kind of help optimize the retrieval, depending upon what information is most relevant for the user. So that kind of dictates how you want to parse the table information and load that downstream into Azure AI Search for retrieval. But it's nice with Azure Doc Intelligence. It kind of gives you that clean format up front that you can really parse through and work through as you need it. So here's a little bit of code example. This isn't like the most groundbreaking code in the world, but what it shows you is the simplicity of how this works with Azure Doc Intelligence. So Azure Doc Intelligence follows the GitHub flavored Markdown format. So what you can see here kind of at the top where it says markdown_content.paragraphs. That allows you to kind of very easily load in the document, let Azure Doc Intelligence do its thing, and then you just pull out paragraphs by reference to .paragraphs in the Markdown. And then from there, it's pretty simple to actually then determine the starting position of the paragraph, the ending position of the paragraph, and then based upon that length, you can also determine how you need to chunk that up in terms of token limitations and counts and things like that, or also use other information in the header of the paragraphs to think about how you're going to do that from an overall semantic chunking perspective. So it's just a little bit of code, kind of shows you how easy it is to kind of pull out the paragraphs and work with that information coming out of Azure Doc Intelligence. And then the next one here is related to the tables. So same thing, markdown_content.tables. So pretty easy again to reference the tables. And then like I said, you can have your fun at however you want to parse up that table information to get it into Azure AI Search to kind of help with the overall retrieval process as part of RAG. All right, so I think in summary, so if you look at RAG in that beginning of the process, again, if you don't get that front end of the process right with how you're chunking, you're embedding your content, everything else downstream doesn't matter. So it's important to make sure you have a reliable solution at that front end of the process. For us, we've had a lot of great success with Azure Doc Intelligence and using that to kind of help us at the front end of the process and really doing this at scale. I mentioned with Chat PwC, we have that rolled out to 200,000 professionals globally. Over 1 year of running that in production, we've seen less than 2% failure rates on Azure Doc Intelligence. That's pretty powerful in the sense of, for us as a company, we need scale and dependable scale and solutions that our professionals can rely on. So those failure rates and the SLAs around latency are critical. And we've been working very closely with Vinod and the team on all that just to make sure that we're getting good, clean, quality output and dependable solutions. So hopefully that was useful. I'll be around if you guys have any other questions. We might have some time for Q&A at the end there, but Vinod, I'll hand it back to you.
Thank you, Jake. That was awesome, and thank you for the amazing work. Yeah.
Good.
So, quick question for you, actually. I saw a lot of text and tables, but not really much images. Do you work with images a lot?
We do. So similar to like that markdown_content, you can find the images as well. So for us, when we're doing large ERP implementations, if you think about implementing like a workflow in SAP or Oracle, for example, there's a lot of images that come in for these functional specifications or technical specifications. So when we parse out all that content from a knowledge embedding perspective, we will use Azure Doc Intelligence to identify the images within the document and then actually read the text off of those process boxes within the image to give us more information too around what is the business process for that solution or those RISE-F objects in SAP or Oracle, and kind of use that to help with our RAG processes.
Cool. Yeah. Thank you so much. Thanks so much for sharing the amazing work your team's doing.
Yeah, you got it. Thanks, man.
Right. Thank you. Thanks. All right, so we heard a lot about how it's garbage in, garbage out with RAG, but we wanted to talk to you a little bit more about some of the other capabilities that you have within Document Intelligence that essentially help you build out this process end to end, so you can optimize for accuracy, optimize for relevance, and optimize for ensuring that you can meet your process needs, right? So I'll talk to you about, I'll give you a quick demo of some of the capabilities, and I'll kind of walk you through some of these in the context of what you've seen today already, right? So I'm going to switch over here to my demo machine, and okay, I'm back. Nothing like a little, demo snafu, but okay. So I'm in the document, I'm in the Azure AI Studio. And this is where I'll kind of start my demos because this is sort of like the newer experience that we're migrating to. Some of the capabilities in document intelligence are already in the new AI Studio. You can try out some of the pre-built models, layout, read, and some of the other models. But some of the existing custom models and things like that are still part of the document intelligence studio. So for this demo, we're going to sort of straddle that fence a little bit and go back and forth. I'm going to start by showing you some of the cool, some of the new capabilities within layout, because that's sort of more pertinent to what Jake was talking about earlier, right? So with layout, you get a model that essentially understands your documents, and it extracts all of the structure and content from these documents. So we'll try this out in a couple of different ways, right? So we'll try this out first with, well, let me start by sort of giving you a couple of options to look at, right? So we'll open the analyze options. And the analyze options, you'll see that I can choose to get just the text output, or I can choose to get the markdown output. And that's what Jake was referring to earlier. So we'll try that out. We'll try the markdown output. But there's also other options that I can choose. Like there's barcodes, there's like medical images or medical forms come with a barcode sort of pasted onto documents. You might need to read those barcodes in order to get a patient ID. So that might be sort of the scenarios that you have there. You need language detection. You want key value pairs. And we'll talk a little bit about key value pairs in a second here. There's also other features that you can choose, right? So I'm going to do that, and I'm going to hit analyze, right? And so when I analyze this particular document, you'll see that the model can come back with all of the content extracted, as well as the structure. And structure includes selection marks, tables, as well as any elements within the document, right? So let's talk about the elements, right? So first is you'll notice that title is a paragraph with a role, and the role has title. So you're now able to start to decompose the document. And this goes back to what Jake was describing earlier, which is you might want to create a context-dense chunk that allows you to ensure that the model gets the best possible context to try to answer the questions. So in a document that has an executive summary, for example, you might want to chunk out the executive summary separately, or you might want to create a specific set of chunks. And so you can now do this because you have this paragraph level information that contains titles, section headers, section bodies, and so forth. You can also do tables, so it extracts tables natively, and it also extracts figures, right? So if you look in here, there should be a section for figures. If I go look at that, it's saying this is the figure as well as this is the caption associated with that figure. So the model just knows how to do this. You might want to treat the figures differently. You might say like, hey, I want to go send the figures to GPT-4o and ask it to sort of like maybe describe that figure or tell me what the net sales were based on this figure for a particular year. Those are all things that you can now do just by using the output of layout. The next model we'll look at is we'll look at invoices as an example, right? Invoices is just one example of a set of pre-built models that are available in document intelligence. So we defined the schema, we trained the model, we extracted the fields, right? That all works well because that document type was really specific to your organization. But when you have documents that are really common and generic, like tax forms, loan applications, mortgage applications, invoices, you don't need to do even that, right? You just use the pre-built model because the pre-built model just works for those types of documents. So in this case, I'm going to turn on a couple of other features in addition to just analyzing this document. The first thing I'll do is I'll use query fields. And query fields, I just put in a supply location as one of the things that I care about. So I'm just going to hit yes, I acknowledge, I add it in, and I continue. The other thing that I'll also do is I'll turn on key value pairs, right? And I'll hit this analyze button, and we'll talk about it in a second here. So with query fields, I can define just a key name that I care about, and I say, I know that this document is going to contain some information in here that is relevant to this. Can you extract that for me? That's what query fields does for you, and it's really powerful because it allows you to extend the schema of any existing model, right? So all you do is you slap on a query field at the end of the query, and you say, these are the fields that I want, and the model just works, and it tries to extract those fields for you. So let's take a look at what we got here, right? So in this case, it obviously extracts all of the fields that I need from the invoice itself. So the fields like the typical fields of the invoice schema are all here. I can also scroll down to the part where at the very end is the supply location. And you can see supply location is from this particular section of the document. the field is called place of supply, right? And so this is one of the core values of query fields, is it allows you to normalize those keys for you, right? So you define what the key is, the model extracts the value, and then you can just use that key in your downstream processing to say, like, whatever the value is for this particular key, take that value and push it into my downstream store. Without this, if you are using sort of key value pairs, the sort of result there would be one where you'd have to go look at what the key is, do a little bit of if then else kind of comparison to see, okay, does this value work? Is this the value of the key? And if it is, then you accept that value and move forward. So those are some of the core capabilities within document intelligence that just allow you to extend the model's capabilities and then embed those models in your document processing workflows. The last thing we'll do is sort of look through the classification model, right? And in classification, I'll need to go back to the old Document Intelligence Studio in order to do this because, like I mentioned, some of the capabilities are still not quite there in the AI Studio. These are still in Document Intelligence Studio. They'll be moving over in probably the next few months. So I'm going to start in the Document Intelligence Studio. I'm already deep linked into the custom classification models space. Custom models work through the same process. You create a project. The project is essentially a connection to your data set with your resource. Once you created the project, you can go ahead and start working with the documents in there. So I'll open a project that's already been created. And you'll notice that I've uploaded my documents into the storage account that I'm working with here. And I've uploaded them in folders. And the model and the service recognizes that those documents are in folders. And it gives me the option to say, like, hey, do you just want to use your folder names as labels? And I'm like, yes, that's perfect. Let's do that, right? So that's all it took for me to label my documents, right? Just that one click is all I needed to do in order to label all of my documents. I go ahead and hit train now. So we'll take a look at this data set in a second here. So we'll just call this build demo, and I confirm and hit train, right? So again, training a custom classifier is pretty fast. It shouldn't take more than a few seconds to train this model. Once the model is trained, I can go ahead and test it, right? So in this case, this was a model that I used 3 different document types with. There was a SOW, there was a PO, and there was, I think, a trade confirmation in it. So once I hit refresh, you'll see the model is actually built. I can go in here and I can test, right? So in order to test this, I actually have a document here that I will pull into my test. And if I look through this document, it's 6 pages. It's got 4 pages of a PO, and it's got a purchase order and a trade confirmation at the very end. So I hit run analyze on this model. So this is actually great that I did that. So now, the default behavior here is that we would treat the entire document as one single document type, right? So it looks at this whole document and says, like, hey, I'm starting with SOW. It looks like most of these are SOWs, so I'm just going to leave it, assume that since you want me to classify the entire file as a single document, this is an SOW for me. But I can go in here and say, I actually want you to split this for me. You take your best guess at splitting the document or splitting the file into individual documents for me. And so now when I run the same analysis, it's going to come back and say, like, oh, actually, only the first 4 pages are SOWs. Then you have a PO and a trade confirmation after that. So this goes back to what we were talking about as sort of like the canonical pattern, right? So you now got a single file that comes in. You split it out into different documents. You can send each of those documents to the appropriate model for analysis, get those outputs, process them the way you need, and now you can save and persist your model as you need to. One final capability that also exists in the Document Intelligence Studio is creating custom extraction models. But I'm not going to demo that for you anymore today because I already showed you one of the ways that you can build custom generative models, which is essentially just another type of custom extraction model. So rather than try to demo another custom extraction model for you, I'm just going to actually ask Jake to come back up here with me. I know that Jake's team has actually been using custom models as well. So Jake, would you mind telling us a little bit about like how PwC is using some of the custom extraction capabilities as well?
Yeah. So generative AI is great, but it's not the solution for everything. So I think a lot of what we've seen in our audit processes too, where we're doing vouching and tracing from different information in the ERP systems to actually what ends up on the financial statements. We have to comb through a lot of purchase order, bill of lading, other purchase agreements, and a lot of different document types. So GenAI can help in some of that, but it's not the solution for everything with a lot of those complex documents. So in that case, we do train custom models through the Azure Doc Intelligence product as well, to kind of help with that very precise based extraction. So because if you think about an audit process, like I have to really rely on the quality of the output. So in some cases, generative AI is a little bit too unpredictable, even if you drop the temperature to 0. So that's why we use the custom models in Azure Doc Intelligence as well.
Well, cool. Thank you so much, Jake, and thank you so much for being here with us today to share your story of like everything that PwC is doing around document processing and essentially helping your customers. So thank you so much for your time.
Yeah, thank you guys.
Yeah, thank you,
Be
everyone.
around.